What's up? Welcome back to Advent of Code. We are almost at the ending of this 2020 journey. So today we're focusing on day 24, and today we are working with an hexagonal grid, which is something a bit peculiar. So that's why I directly thought about this link. Which is a really great resource for a lot of different things. There is the A-star, a really nice A-star tutorial there. I loved it, so that's really good thing to check. I think it was this one. It appeared a while ago, and I really loved it when it appeared. And today we are working with this hexagonal grid thingy, like article, and there is something called map storage, and this is really brilliant because we see how we can work with like an array, how we can transfer an hexagonal map into a 2D map. That's going to make it a lot easier for us because we're going to be able to understand this really cleanly. So I really like that. This is an array of array. This is perfect for us. This is going to make it a lot easier for us. So first of all, we have this input. And of course, as usual, we paste the input here. By the way, today I'm using CodeSpace instead of using Gitpod, but this is a very similar tool. So first of all, we need to do some parsing here because we have these words that are all concatenated together, and these are the possible options. And the best way to do that is to start using a regular expression. We want to have a regular expression and check these, and we want to match to extract all of these. So you know what, we're just going to do for of. We're going to be doing a for of line of lines, and in here we're going to do line.match all. Isn't there like a match all? Maybe it's a regular expression.match all. Let's do that right away. This dot match all. Oh, time to check the ducks. Okay, so the ducks say this is string.match all. So line.match all. And here we can use the regular expression that we have crafted, and this is returning not really an array, so we have to do this, and then we want to take the first position. So here const direction. If we do that, we're going to be logging the direction to just really, we go step by step, so that's it makes a lot of sense when it's done. Day 24, we are already day 24. It is crazy. This month is going so fast. So here we want to convert this object into an array. And now we have exactly what we want, except we just care about this first part. So here we're going to map that x, and we want to return x of 0 here. So that's, yeah, we have an array of coordinates for each line, which makes perfect sense. Now, what we want to do is we want to go through each of those. We're going to need, first of all, to create a let x and y, because we want to start at this coordinate. It's not really important. And then for each of these directions, we need to move. Are we starting always from the reference style? Yeah, each line starting from a reference style. So this means that here we need to say x equals 0 at that point and y equals 0. So here we can do that, I believe. And then we have our directions actually, and we need to loop let's do a little for off, direction out of directions, and now we need to do x plus equal something, y plus equal something. And this is something that we're gonna get thanks to that here. So let's say we are starting on 3, 3. If we go northwest, it's 3, 2. So let's create a thing here, const direction to delta. And here we're going to say, for example, northwest. And dx is going to be it's going to be -1, and y is going to be 0. dx is -1 and dy is 0. So we're going to need to do that for each coordinates. Let's do a second one, and then I'm going to skip in the future. So we can do, for example, east. So east, we just take this. Wait, you know what? I think I should paste this link here to make it clear. If you want to check the link, it is in the source code, and I will put that in the description of the video. So west is, of course, we just have to remove 1 to x and keep the same y. So, okay, this is east. Let's say west. We do, wait. This doesn't make sense here. I believe here I already made a mistake. Northwest, it is on the same x, but -1 in terms of y. Can we confirm here? Yeah, northwest. So here this is the same x, but different, but -1 in terms of y. Whereas here this is -1 in terms of x and the same y. So yeah, I'm gonna fill that quickly. Okay, I've filled all of these. I've tried to debug it visually, but there might be an issue, so we're gonna need to be careful about that later down the road. But you know what? I think with this visual representation, it's quite clear. So anyway, we're gonna be doing that. So here for the direction, we're gonna say direction to delta of direction dot dx, and we're gonna do the same for dy. This is gonna basically make our x and y move in the space, and then we just have to flip a specific tile. So the tile that we want to flip is when we end this. The tile that we end up at, we need to flip it, right? It's white and then it's black. So what I'm gonna do here, I'm gonna be using a set, and we're gonna only keep the black tiles. We're gonna try that. Const black tiles equal to new set. And there is no black tiles at the beginning. That's the interesting thing. And here we can say if black tile that has here we need to concatenate x and y. That's a bit annoying, but that's not a problem. Const key equal this is x plus, I like putting the hash in middle to make sure there is no issue. So if black tile has the key, then we can black tiles that remove or delete key, which means it is not black anymore. The tile is now back to white. And in the opposite case, we have to say black tiles dot set, not dot add. I'm always forgetting the interface of a set, but here that's quite good. You know what? I think one issue that I failed is that I don't remember how many tiles are left with the black side up. So that's really good, because we just have to do console.log black tiles dot size. That should be all, 16. Let's see, is that the right answer? That is not the right answer. In the above example, 10 tiles are flipped black. Okay, so there is 10 tiles that are black in the end. So this is not good. So we're gonna have to double check that. So one thing that would be good would be to visualize a bit this. Let's, you know what, let's log the key. So actually we need to log the key here. We can log the key and we log black tiles that has key. So when this is false, after this is true, so that's good. So here we have everything that is false. Wait, there is a couple of true. Let's highlight the true values, true and true. So there are just 2 tiles that we switch back to white. 10 tiles are flipped once to black, 5 more are flipped twice. Let's double check that we have the full example, because that would be a silly mistake. I think this is time to read the prime statement one more time. Okay, so I think it is time. I've read the full prime statement and looks like we are doing something good. So it is time to go back to an even simpler example. This one should be northwest, west, southwest, east, east. So if we take this, we start at 3, 3, northwest, west, southwest. So northwest, west, southwest, east, east. We should land on the same spot, which is 0, 0. However, here we land on 1, 0. So we definitely have an issue with this. You know, I've done that quickly, and so of course there is something to check. So let's check. Northwest is 0 minus 1 and northeast 1 minus 1. So northwest, wait, is that x first and y second? Here, this is 0 minus 1 and 1 minus 1. So we are good for northwest, northeast. We check that a couple of times. West and east. West is going to the left, east is going to the right. So everything is fine. Southwest. Southwest is, just wait. 3, 3, we have 2, 4 here. So this is, what the hell here? Something weird is happening. I was not expecting that. 3, 3, we have 2, 4. Okay, so here we need to do -1 plus 1 for northwest. Northwest, -1 here, plus 1. And southeast, it is, just 0 and plus 1. Okay, so I think we fixed it. Let's try that. Actually, we need to land back on 0, 0. Now we are good. So yeah, this is all about visualizing this thing correctly and doing this object right. Now that we've done that, we can go back here to the previous example. We should see 10, and we have 10, which is very relieving. I can remove this debugging line. We have 10, and it is time to go back to the full puzzle input. That feels good. Let's do that. Let's see, 394. Looks like a good number. Is that the right one? And it is! Yes! let's jump right in to part 2. Is that a day where I can make part 2 or not? I'm gonna check this right away. Oh, this looks really fun. Today we have another game of life, you know, like this kind of cell automation game or visualization. Every day, every step, we have like a tile that changes depending on the tiles around them. So that's something that we know now. We know how to do that. Let me see. Okay, so here we still start from the previous step, I believe. So you know what? Right away, we're gonna go back to the smaller input, and we go on to part 2. So in that case, we need to keep the black tiles. We're gonna do a let because we want every step to be changing that. So here we're gonna say new black tiles, new set. Actually, we're gonna loop that. We're gonna put that in a loop. Between 10. I believe it was 10 days. Is that it? 100 days actually. So we want 100 steps. And the first thing is to create a new black tiles, and the last thing is to say black tiles equal new black tiles. It's good to, you know, set up the structure right away to make sure we don't forget anything. So in here we need to update everything. So one thing would be to go through the wall space, you know. That's the strategy that we chose last time. But I think we could just, you know, go check all the black tiles and the neighbors of the black tiles. So we're gonna need to do that right now. We need a function get neighbors and current cell with x and a y, and basically we're gonna say const results. This is gonna be quite simple because we have to just do something similar to that, which is we have to push in result.push x. This is the current x plus this dx, and y, this is the current y plus this dy. This and this. However, if we do that, we just get the neighboring cells. We don't get the current cell itself. So here we have to add x and y, which is the current cell. So we can do a for of. Can we do that? Iterator of object. So tile of black tiles dot values dot keys. That's gonna be annoying because I'm gonna have to convert that back. Const keys equal that. Const here we need x and oh no, we need to say x y is equal so xy is going to be equal keys dot tile dot split. We need to split on the hash that we added, and I'm going to use a map to do a parse int to make sure we actually have integers in x and y. So you know what, I'm not feeling super confident, so I'm just going to be displaying x and y, and I'm going to be breaking here. With that, we should see a bit like a couple of x and y's. Looks good, you know. I wasn't expecting any more than a list of tuples of integers, so that's good. Now, what do we need to do? we have all of the black cells, so we need two black tiles. Now we need to return const neighbors. We're gonna say get neighbors and current cell of X and Y. And now we're gonna say for each of these, for cell const cell of neighbors, that's where the logic is gonna happen. So now we're gonna need to say const actually here I don't like this for this thing when we have the current cell, so I'm going to be removing it here, and instead we're going to rename this function just get neighbors, because this is going to be more reusable. Get neighbors looks better, and we need to say neighbors that push X and Y, so that we add the current cell. And now we go back here and we do, here we need only the neighbors. Okay, that's going to be confusing. I need to change this. Const cells around, and now we get neighbor of cell.x, cell.y. And here we need to filter, we need to check to filter the neighbors to cell. We need to filter the neighbors so that we only get the neighbors that have a black cell. Black tiles that has cell, and here we have an issue, which is we are doing this here. I don't like that. I would much rather do coordinates to ID, and here we can return x plus hash plus y, so that this is reusable. Otherwise this is just confusing. So key coordinates to ID of x, y, much better, because now we can reuse this here has coordinates to ID cell.x, cell.y. So in here what we do is we get all the neighbors. You know what, I'm gonna do that on several lines. Neighbors, otherwise it's a bit confusing. Const black neighbors, it's neighbors dot filter, and now black tile. Oh, what's up? Sorry, I lost my screen for a second. Okay, I'm back with this thing, black tile. So here total black tiles is this dot length. You know what, I think it's weird to make that on like 10 lines. That could be a one-liner. So total black tiles here, and now we need to check 0 or more than 2. Any black tile with 0 or more than 2 black tiles is flipped to white. So we need to check if the current cell is black or not. So let's check that. If coordinate, oh no, that's the full formula to check if the current cell is black or not. Has, okay, so here we're going to say n instead of cell because that's confusing. Okay, nx, ny. Here we say black tiles has, so in that case the current cell is black. we need to check if it has 0 or more than 2 black tiles, then it's flipped to white. So in that case, we check if this is set to 0 or this is more than 2. Is that strictly 0 or more than 2 black tiles immediately adjacent to it? I don't know exactly what happens when there is exactly 2 black tiles. Is that... Oh yeah, okay, no. Here exactly. It's okay, so more than 2, it's flipped to white. So more than 2, then it's flipped to white. How do you flip something to white? Here needs a const current ID, because otherwise I'm going to call this function so many times. So here, like that, we say has. In that case, we say black tiles dot delete current ID. Current ID. In that case, we are good. Otherwise, it means that this is a white cell. And in the case of a white cell, we want exactly 2 black tiles. Then it's flipped to black. If total black tiles is exactly equal to 2, in that case we do black tiles dot push current ID. I believe we have everything going right. The good thing would be to use this. You know what? We're gonna just be launching it right away. I am missing something. Okay. Here we have this direction that is not defined here. Neighbors. Oh, we don't need directions. We want this direction to delta. My bad. This direction to delta. No? Yeah, so actually, what have we done here? We want for each possible direction to delta. Let's do that. Direction in, direction to delta. Then we have direction to delta of direction. We should be good here. Let's run that again. Okay, I made push here. I need to add instead. You know, that's a set, so we need to use the function add to add something to the elements. And here it is taking forever, which is not looking good, not looking good. So what I would do here, I would stop that, and instead here I would check here log the day. So it should be between day 1. Okay, day 1 should be, okay, so let's log I, and we should be logging, actually we should be logging at the beginning here. Should say day 1 we have black tiles dot size black tiles 1 and 10. Okay, so maybe here we already have flipped something, so that should be at the end of day 1. Okay, so we're making progress little by little, you know. And here we have an infinite loop somewhere, and I don't like that. Let's see. Here we're going to be logging the current ID. That's going to be an infinite loop, so it's going to be crazy. Okay, so that's so many options here. I've made something wrong. I've done something wrong. So we should stop this infinite loop if I can. Yeah, Control C, that works. That worked in the end. Okay, so here, I know what, I'm going to be logging this x, y. Okay, so we have a bunch of x, y's. They look different, which would be good. How many keys do we have here? Log keys. We don't have that many keys, so that looks good, you know. However, we have here 10 minus 17. That's not good. So basically what we want to be doing here, we want to go on each black tile and check all of the cells around it and the black tile itself. And for all of these cells around, we want to get the ID of this specific cell, and then we want to count how many neighbors are black tiles, and then we do this logic here. Oh, look at that. This is a big mistake. You know, rubber ducking debugging is really good. I was talking to you, just trying to rephrase everything, and now I've seen the obvious. Here you can't delete on black tiles, you need to delete on the next iteration. And if this is and here, if this is not happening, here we need to keep it black. So in that case, we need to add the current ID. Wow. Yeah, I believe this is it. If this is a black tile, in that case, we need to remove it. And in that case, we need to add it. So actually, I think this is not even going to be needed, this line. But we're going to keep it, you know. Let's try that again. So now I am never modifying the black tiles. I'm just checking if it has something, and I'm modifying it here after the loop. Let's try that again. Okay, so I need to remove all of these console logs because this is insane. We don't know which day we are anymore. So we are logging some stuff here. Let's remove it completely. We're logging stuff here, that's fine. Actually, that's not fine. I need to remove this one as well. And this is one of these infinite loops where you can't even stop. My interrupt is not reaching the code space servers. I'm gonna wait for a second. Okay, just had a little bug with the IDE right now. Let me run that. I don't want to run that again. Yeah, I want to run that again because now it should be good. Let's see what is the expected thing. 2208. Okay, 2208. This is not the expected result. So we have some issues, but you know, that's fine. Day 1 is 15, day 2 is 12. Okay, so it looks like it's starting in a good way, good shape. 25, 14, 23, 28, 41, 37, 49. Huh, this is really good, like everything aligns perfectly. Step 90 is 1, 8. Okay, so I think I need to just add one more day. That was it, that was it. Okay, 2208. 2208, we have the right answer, so I think we should be good. I'm gonna be getting the puzzle input right away. I think if I do like that, a little shortcut. No, never mind. I failed everything. I'm gonna grab the data in here, paste it here, and we should be. in a great position now. Just gonna launch that. The day passes by like crazy and we have 4,036. Is that my correct answer? Yes, it is. Thank you so much for the support in this series. Don't forget to drop a like and see you in the next one. Bye bye.